In the last video, we didn't actually end up calculating any final answers for those probability questions. So that's what we'll do in this video. We're going to calculate the probabilities of some independent events. The formula for that is just the probability of event A happening and event B happening is equal to the probability of event A times the probability of event B. So we'll start with an example here with this spinner shown in the picture, where we have an equal chance of landing on any of these 8 sections. So in the first example, we will determine the probability of spinning a 4, then a 2. Well, based on what we know about dependent and independent events, we can say that spinning a 4 the first time is not going to change our chances of what we spin the second time. So these are independent, which means we can use the formula from the last page and just say this is the same as probability of 4 times the probability of spinning a 2. Well, the probability of spinning a 4 is 1, 2, 3 successes out of 8. And then the probability of spinning a 2 is just 1 out of 8. And if we do that math out, we end up getting that our probability of getting a 4 then a 2 is 3 over 64. We can also do this with more than 2 consecutive events. Let's say we want to determine the probability of spinning red, then a 1, then green. They're still all independent because one event happening does not affect the chances of the next one. So to find this probability of red, then 1, then green, we just have to multiply them all together. So probability of red times the probability of 1 times the probability of green. Well, the probability of getting a red is 1, 2 out of 8 times the probability of getting a 1 is 1, 2, 3, 4 out of 8 times the probability of getting a green is 1, 2, 3 out of 8. And when you multiply all of these fractions together and simplify, you coincidentally end up with the same answer as we did above of 3/64. Let's take one more example. You roll 2 dice, determine the probability that you roll a 6 on the first die and an odd number on the second die. Well, rolling a 6 on the first dice does not change my chances of getting an odd number on the second one, so these are 2 independent events. Which means we can calculate this as just the probability of 6 times the probability of odd. Well, the probability of rolling a 6 on a 6-sided dice is just 1 out of 6. There's only one way to do it. Times probability of getting an odd, well, for an odd number there's 1, 3, and 5. So there are 3 successes out of 6 possible options, leaving us with our final answer of 3 out of 36, or just 1/12.